Let's write a little bit of Python code to calculate the energy of a photon using the equation E of photon equals h nu. It says create a variable named frequency and store your answer from the previous calculation. So I'm going to go ahead and write frequency and it does want to complete with this frequency, which is not matching the previous one. So I'm going to go ahead and type in or just copy paste from above. So that means 4.57 times 10 to the 14th power. And define a function named E photon, and this function should take in frequency and return the energy of the emitted photons. So to do that, I have to define my variable Planck's constant as 6.626 times 10 to the negative 34th. Remember, the double stars is scientific notation. And so I've defined Planck's constant there, and now let's create our function that will calculate photon energy. So I'm going to say def, and this looks pretty good. So tab will allow you to accept if you like how that's written, how it's suggested. So E photon calc, right? And it will take one input, the frequency. Inside the function, we'll tell Python to return. What we could do is define the function as we did above and say return h frequency without doing this. That way we have a reusable function. It will calculate the energy of a photon for any frequency that we give it. So I'll run that and see how that goes. I get the check mark, so that means it's good. Run the next block. And it gives the calculated value 3.03 times 10 to the negative 19th. So in this case, 3.03 times 10 to the negative 19th joules will be the energy. All right, in this one, what we're going to do is use the equation delta E equals negative the energy of the photon. That just means the change in energy, the delta E, is the negative of the magnitude of the photon energy. So we take the photon's energy, making sure that we use its positive size, in other words, the absolute value, and then put a minus sign in front of it to indicate that the energy is being lost. So it says to create a variable named E photon on equals, and I'm going to grab the energy it gave me before. And then I'm going to define my function, E delta calculated, and we're going to pass in a variable here, and it doesn't have to be the same as the one up here. So up here, I'm storing the photon energy in a variable called E photon, and here I'm defining a function named E delta calculated, E delta calc. And the part inside parentheses, E pho, is the function's input, a placeholder name that will hold whatever energy value we pass into the function. This name only needs to make sense inside the function. It doesn't have to match the variable that we used up here, if that makes sense. So now we're going to return the negative absolute value of E pho. Thus the minus sign in front makes the result negative. So whatever energy we had in this function, it's going to return the negative of its magnitude, which is what we need because we know that this is an energy release. So in two small pieces, this stored value and stored function allow for a clear, reusable, robust code that, corrects for any sign mistakes. So we don't have to worry about getting an answer with the wrong sign. I'm going to run the next block of code, and it's going to say, okay, yes, the negative of what I put in, and that would make good sense. It does say there is an issue with your code. And I can check to see what that is real quick. I think maybe order of operations could be better here. Not sure what else I could improve. Otherwise, it looks okay.